Alright, so topic number 3 is going to be about applications of the Pythagorean theorem, so we're pretty much going to talk about word problems. And the steps that are important to solving word problems are to first draw a diagram, label your diagram, and then these last 3 steps here are really using the Pythagorean theorem. Okay? So when you're going to use the Pythagorean theorem, you're going to identify the hypotenuse first, make your equation, and then you're going to solve. Okay? So there's going to be 5 different types of problems that we're going to work through and that you're going to practice, and then we'll start building on those examples a little bit more and looking at new ones. Okay? So let's start with drawing the picture first for number 1. A 25-foot ladder is placed 24 feet from a building. How high up the building does the ladder reach? Okay. In this problem, we're not actually going to need to approximate. That is a typo, so you can cross that out. So when I draw a picture here, I have a building, okay, and I'm saying that there's a ladder that's leaning against the building. So here's my ladder, okay, and then I have obviously the ground that they sit on, okay, and so in each of these problems, what I want you to try to find is I want you to try to find the right triangle. So if you notice, the building, the ground, and the ladder, they make a right triangle that we could use the Pythagorean theorem on. And now let's label. Notice I have 2 knowns, and I have 1 unknown that I'm trying to figure out. Now, a 25-foot ladder, that's going to be the length that you would actually climb up. I would climb up 25 feet. So that's the length of the ladder. And I'm saying that this is placed 24 feet from the building. So here's the bottom of the building, here's the bottom of the ladder, and it's placed 24 feet away. Okay? And now it says, how high up? So from the ground going up, how high does it reach? That's going to be my x. So really, I'm looking at this triangle, where the hypotenuse is 25, one of the legs is 24, and I'm finding the other leg, okay? So we can use c squared equals a squared plus b squared, and we can solve. C is the hypotenuse, that is 25, so 25 squared equals 24 squared plus x squared, and since you guys already know the Pythagorean theorem now, you could solve this from here, so let's go through the steps quickly. You should get 625 equals, I think it's 576 plus x squared. Hopefully that's correct. And then subtracting 576, I think you would get 49 equals x squared. Take the square root, and x is 7. And don't forget your units. So this was feet. This is 7 feet. So the ladder reaches 7 feet high. Okay? Let's look at number 2. It says Mr. Lee speed walks 6 blocks to the south and 8 blocks to the east. How far is he from his starting point? Again, at this point, this was a mistake. We're not going to need to round on this one. We're actually going to get an exact answer, so we can cancel that out. Let's just remind ourselves that going up is north, going down is south, right is east, and left is west. Okay, so if you're someone that doesn't remember that very well, I would write that down in your notes. All right, and now step 1, let's draw a picture. So he's going to start at a specific point, right? Let's say this is his starting point, and he's going to walk south first. So he walks south until he gets to this other point here. How far did he just walk? He went 6 blocks south, so I'm going to label that with a 6. And then what did he do? He went 8 blocks east. And now from that point, he went 8 blocks east. Now the direct distance, how far away is he from his starting point? The most direct distance is if I just drew a straight line between where he started and where he ended. That's the distance that I want to know. Okay? And notice that all of these directions here intersect at 90-degree angles, so I know this is a right triangle. And here we are. I have a right triangle. I know 2 sides. I'm missing the third. We can use the Pythagorean theorem. So I have x squared, that's my hypotenuse, equaling 6 squared plus 8 squared. And I think that at this point, everyone in our class could finish this problem. I'm very confident. So we have x squared equaling 36 plus 64. 36 plus 64 is 100. Take the square root of both sides, and you should get x equals 10. And now don't forget our units. 10 what? 10 blocks. And there's my answer. Okay? So we have objects leaning up against something creating a triangle, and then actually directions that you use when you could be walking or driving or something that would create a right triangle. Let's look at example number 3. 3, 4, and 5 are all about geometry, okay? So the first one is going to be about a rectangle, then it's going to be about a square, and then we're going to talk about a rhombus, okay? So when it says find the missing side of a rectangle whose diagonal is 13 inches and whose side length is 5. So let's draw a rectangle, okay? And then let's draw in our diagonal. And let's label that 13, okay? And then I'm going to say a side length, which you can pick one, whichever one you would like. I'm going to pick this one along the side here, okay? This is 5. And I want to know what the missing side is. So the missing side would be the longer side here. And now the trick is, again, look for that right triangle. We know that all of the angles in a rectangle are 90 degrees. And if you look at half of this rectangle, I have a right triangle. So let's identify the hypotenuse. It's going to be 13. And let's use the Pythagorean theorem. C squared, oops, sorry, my pen's not working, equals a squared plus b squared. All right? C is 13, so 13 squared equals 5 squared plus x squared. And again, we could solve this from here. 169 equals 25 plus x squared. Subtract subtract 25. I believe it's 144. You guys can double check for me. Square root, and I get x equals 12 inches. And there's my answer. Okay. Let's do an example with a square. So now it says the diagonal of a square is 10 centimeters. So I have a square. And now what's special about a square? I'm still going to have that diagonal in here. Okay? And in this case, they still did tell me the length of the diagonal. So that's going to be 10, right? And then I still know that all of the angles are 90. And hopefully you kind of see, you can see the right triangle just like we did in example 3. But the tricky part is here. It's saying how long is the side of the square. But I only know one side here. I have two things that are missing. And the trick in this problem is that we know that all sides of a square are congruent. So if I call this side x, this side also has to be x as well. Okay? So you actually can use the Pythagorean theorem. So let's solve. We have c squared equals a squared plus b squared. In this case, c, the hypotenuse, is 10. 10 squared equals, and I'm just going to have x squared plus x squared. Now this is a little bit different than the other problems that we've had. When I do x squared plus x squared, that actually means I have two of them now. Ooh, that was a big mistake there. I have two x squareds, okay? That's going to equal 10 squared, which we know is 100. At this point, before I can square root, I have to divide by that 2. So 100 divided by 2 is 50 equals x squared. And now I can square root. And remember that we have the exact answer here would be x equals the square root of 50. And the estimated answer would be, to 2 decimals, x equals 7.07 using my calculator. Okay, now the one thing that's missing from my problem is units, so make sure you put in centimeters in both of your answers. Okay, I'm going to box the decimal because that makes more sense for a word problem to me, to know what the actual length is as a decimal, okay? Let's look at example number 5. I'm actually going to give us a new sheet so it doesn't look too crazy, okay? So example number 5 says that the diagonals of a rhombus, all right? I've drawn the rhombus for you, measure 8 and 16. That means that there are 2 of them, right? So I'm going to draw in the 8 and I'm going to draw in the 16. I want to know the measure of one side of the rhombus. So let's say I want to know this side over here. Well, what we do know about a rhombus is that all of the sides are equal. So if I have one of them, I know all of them. Let's draw in the diagonals. So this diagonal here is 16. I'm not going to label it just quite yet because when I draw in the other diagonal, something special happens. Okay? Remember from unit number 5 that when the diagonals cross each other, they actually bisect each other. So this red diagonal here is 16, but that's going to get split up into 8 and 8. And this blue diagonal here is 8, but it's going to get bisected and become 4 and 4. Okay? And then the other property that we want to remember is that both of these diagonals intersect at 90 degrees. They're perpendicular. So all 4 of these angles are 90 degrees. Now, word problems. You're always looking for those right triangles, right? So we have 4 triangles in here, and if we highlight and zero in on one of those triangles, what we can see is that that is a right triangle, right? I have a right triangle where I know one side length is 4, one leg is 4, the other leg is 8, and the hypotenuse is unknown. So we can use the Pythagorean theorem. I can say c squared equals a squared plus b squared. C is x. X squared equals 8 squared plus 4 squared. X squared equals 64 plus 16. Add these two together. 64 plus 16, I get x squared equals, I think that's 80. Take the square root. And remember, we have 2 answers. I have my exact answer would be x equals the square root of 80 inches. But again, it's hard to know like what the actual length is. I think the estimate is probably a better answer to use for word problems. And so the estimate to 2 decimals is x equals 8.94 inches. And there's my answer. Okay? So I hope this helps going over the word problems, and good luck with your assignments. Have a great night.